Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
So this is your diagram, and IP addresses are pre-configured on all devices, and according to this diagram today we have to configure OSPF. So in this diagram you can see that area 0 is configured, area 1 is configured, area 2 is also available, as well as area 3 is also available, is not it? And here also we will require to configure virtual links as well, because we are having a concept of discontinuous areas. Like this time area 2 is not directly connected with area 0. Area 0 is running in between R1 and R2, and then you can see area 1 is running in between R1, R3, R2, R4, R5 and R6. Then area 2 is running in between R5, R6, R7 and R8. Then area 3 is running in between R1, R9, 10 and R11. Fine. Each area is having multiple exit points. Each area, whether you are talking about area 1, 2, 3, 4, area 0, 1, 2, 3. In all areas you are having multiple exit points, right? So there will not be any problem related to redundancy. Means that if any one of the router goes down, then of course there will not be any problem in your existing network. So yes, let's do one thing now. Here one more thing that I would like to tell you, that here on each device, as per their loopback, as per their lane, I'm using like 1111 on R1, 2222 on R2, 3333 on R3, on R10, 10, 10, 10, 10, 10, on R11, 11, 11, 11, 11, something like that, on R8, 8, 8, 8, 8, 8. So it will be easy for you to find out that okay, this network is on R8 or it is on R7, right? Even you can check it out on R1 itself. Do show IP interface brief. Loopback is having this 111111. Any problem? And in same manner I'll be configuring their router IDs. In previous class, do you remember that I configured router ID differently from the IP address, from the loopback interface IP address, right? So I hope that we have understood the uses of router ID in OSPF, right? So in case if I am advertising router ID, if I have configured router ID to your any interface of your device, or if I have not configured that router ID as IP address on any interface of your device, it doesn't matter. It does not create any difference. Are you getting my point? Fine. So this time let's do one thing on R1 itself. Start configuring OSPF. So say router OSPF 1, router ID is going to be now 1.1.1, interface S1 by 0. Tell me area is what? 0, and I will also put its loopback inside area 0 itself. Then on its S1 by 1, because it is in area 1, and S1 by 2 is in area 3. So as per this diagram I have configured this router now. Show IP OSPF interface brief. You can check that on which interface which area is configured, right? So you can see that I have put the loopback of R1 in area 0 itself, and S1 by 0, because as per diagram it is part of area 0. S1 by 1 is part of area 1, whereas S1 by 2 is part of area 3. So as per the diagram I have configured it. Now let's move on R2. As per diagram I will also configure this R2 as well. So router OSPF 1, router ID is going to be 2222, interface S1 by 0, IP OSPF 1, area is going to be 0. Loopback 1 will also be in area 0. Interface S1 by 1 will be in area 1. Interface S1 by 2 will be in area 3. So now you can see show IP. So what I configured, right? So this time you can see that we have configured all interfaces of this device as well. Now show IP OSPF neighbor. It has already formed a neighborship with R1 within area 0. So how many router LSs will be there in area 0? Only 2, because only 2 routers are participating, right? Let's move on R3 now. You know very well that all interfaces of R3 will be in area 1. So router OSPF 1, router ID is going to be 333, say network 000, 245, 245, 245, and area will be 1. So you will see that on all interfaces of this device R3, OSPF area 1 will get enabled. So now show IP OSPF interface brief. You can check that area 1 has enabled on all interfaces of this device, right? Then let's do one thing. Let's move on R4, and on R4 also I will say router OSPF 1, router ID is going to be 4.4.4, and then say network 000, because on all interfaces of R4 also you will enable area 1. So you will see that now R4 will form neighborship with R2 as well as with R3. Then let's move on R5. On R5 you cannot configure 000 command, because some of the interfaces are participating in area 1 and some of the interfaces are participating in area 2. So this time you can see interface S1 by 0 is in OSPF area 1. The loopback will also be in area 1, but serial 1 by 1, you understand, will be in area 2, and serial 1 by 2 will also be in area. See, this link in between R5 and R6 is in area 2. This link in between R5 and R6.
Yeah.
That is why I put this S1 by 1 and S1 by 2, both of them in area 2 on R5. So now on R5 you can check this configuration now. So as per diagram I have configured it. Now let's do one thing, let's move on R6, and on R6 as well you have to do the same configuration. Router ID must be 66666, interface S1 by 0, IP OSPF1 area is what? 2, interface S1 by 1 will be in area 1, S1 by 2 will be in area 2, interface loopback 1 will be in area. Show IP OSPF interface brief. So you can see now it must be having two different neighbors with R4 as well as R5. With R4 it is having neighborship in area 1, whereas with R5 it is having neighborship in area 2. Then after, let's move on R7. On R7 you know very well that all interfaces of R7 are participating in area 2. So router OSPF1, router ID is what? 7.7.7, network 000, 245, and area will be 2. So it must form neighborship with R5 now. So it has formed neighborship with R5. Then let's move on R8. Router OSPF1, router ID is what? 8.8.8, interface S1 by 1, IP, yes, interface S1 by 1, say IP OSPF1 area is going to be 2, S1 by 0 as well will be in area 2 itself, loopback of it will also be in area 2 itself. I did use 000 command here. What? Yes, because in future I'll be using this link as well, which will be part of RAP only. That's why I have not used here 000 command, right? However, I will let you know that what can happen, but don't worry, just forget about R13. Let's assume that R13 is not there, is not available here on R8. Forget about it for some time, right?
Yeah.
Just for now, forget about EIGRP as well as RAP. Just think that OSPF is running in this diagram. Now, after configuring OSPF on R7 and R8, let's move on R9. And on R9, you will say router OSPF 1, router ID is going to be 9.9.9, and all interfaces of this device will be in area 3. On R10 as well, no, interface S1 by, and area will be S1 by 1 will also be in area, loopback 1 will also be in area 3. So you see, show IP OSPF neighbor. Fine, no problem. You have configured everything here in this network, in this diagram. You have configured OSPF completely now. After doing this configuration of OSPF, we are on R11. So how many APRs are there available in area 3?
Two APRs.
Two APRs are available, is not it? Two different APRs are available in area 3. Even if you configure this command show IP OSPF board and router, then you will come to know that okay, R1 and R2, both of them are working as an APR. And from our router R11, the cost to reach both APRs is, is not it? 128, 128. This is the cost to reach these APRs.
Yeah.
So from here to reach both APRs, the cost is same. Even if you move on R10 and then if you configure this command, so if you SPF border router, so you will come to know that from here the cost to reach R1 is 192, whereas the cost to reach 2222, I mean R2 is what?
64.
Understood? So right now it has proved that for area 3, how many ABRs are there? 2 ABRs are available, right? And now let's move back again on R11. Now R11 must have all routes available inside its own routing table except routes coming from area 2, because area 2 is not directly connected with area. Understood? So this time let's do one thing, show IP route. Say show IP route. Even it will be better for us to see like this. Does it have that? It does not have that. Even if you move on R7 now, and if you say show IP route, you will be having only intra area. There is no single inter area, because for area 2 there is no border route. And if there is no ABR for any area, in that case, within that area you cannot find inter area prefixes. To have inter area prefixes, it is mandatory to have an ABR. Understood? Fine. So now to have an ABR in this area too, what can we do here? To solve this problem, what can we do? Perform redistribution on R5 and R6 or configure virtual link. So I have proved all these things. So today I'm just gonna to configure virtual link here over area 1. So I'll be configuring virtual link in between R1 and R5, and then I can also configure virtual link in between R1 and R6 as well. But here it will be better for us to configure virtual link in between R1 and R5 and R2 and R6. That's fine. It will be enough for us, right? However, here we can have 4 virtual links, but I'll be having only 2 virtual links in between R1 and R5 and then R2 and R6. Otherwise, we could have like virtual link in between R1 and R5, R1 and R6, and then R2 and R5, and then R2 and R6. Is not it? So then after, see, right now R5 and R6 are not working as an ABR, but once I will configure virtual link here in between R1 and R5 and then R2 and R6, you will see that virtual link will be, these 2 routers R5 and R6 will become as an ABR. So do one thing, move on R1 now. Router of OSPF1 area 1 is virtual link with whom? 5.5.5. In same manner, I will move on R2. On R2 also I will say router of OSPF1 area 1 is virtual link with whom? 6.6.6. Then after I will move on R5. On R5 also I will say router of OSPF1 area 1 virtual link with whom? 1.1.1. And then I will move on R6. On R6 I will configure this command that area 1 virtual link with whom? So you will see that now virtual link neighborship will come up in between R1 and R5 and then R2 and R6, and then after R5 and R6 will start to do work as an ABR. See, virtual link neighborship have came up here, and on R5 also you can see that virtual link neighborship have came up. It means now R5 and R6 must have an entire database of area 0 as well. So if you OSPF database, you can see that now how many routers are participating in area 0? 4. See, 4. Because R1, R2 were already there inside area 0, but now after configuring virtual link, R5 and R6 have also started to participate in area 0 as well, right? So this time you are having 4 router LSAs available inside the database of area 0, and apart from these 4 router LSAs, all others are coming as summary LSAs, and whatever will come via virtual link DNA bit will be set onto that, right? Yeah. So I have already taught you the rules, all the rules related to all these things, right? Because as I said that if anything is coming via demand circuit, then DNA bit will be set onto it automatically, even though hellos will also be suppressed. So if you move on R6 as well, then you can run this command show IP database. So you can see that now area 0's database is there, right? And then after you can also run this command show IP OSPF, so it must work as an ABR now. This is R6 in same manner.
सर R5 और R6 के लूपबैक एरिया 1 में है, इसलिए R5 पे R6 के जो भी LSS दिख रहे हैं वो उसको DNA पे शेयर है.
What loopback? R5
R5 के डेटा
वो तो वर्चुअल लिंक आ गया ना एरिया 0 में।
वर्चुअल लिंक आ गया, लेकिन R6 का लूप बैक एरिया 1 में है,
हाँ
तो उसके कारण डीएनए बिट चलेगा ना। अगर वो एरिया 2 में होता
नहीं तो उससे क्या मतलब है?
तो उसके लिए तो इंट्रा एरिया
क्या कर रहा है? R5 on R5 you check database, try to SQL database of area 0. It cannot receive the database of area 0 from R6 itself, because with R6 it is having neighborship within area 2. There is very simple rule. Whatever the information, whatever the LSA will come via virtual link, DNA bit will be set onto it. Fan off kar do. Fine. So in this way it will work. So after configuring virtual link over area 1, you can see that it has started to work perfectly. Even like if you move on R7 now, if you configure this command show IP OSPF border router.
rule बता दे.
What rule? I already told you that whatever the information will come through the demand circuit, DNA bit will be set onto that. So this time, because R5 was receiving whole database of area 0 via virtual link itself, that's why DNA bit was set onto all those LSs which came through virtual link, because by default OSPF runs this virtual link as a demand circuit. Fine. So this time for area 2, how many ABRs are there? 2 R5 and R6. Both of them have started to do work as an ABR. And now here there are 2 entries for R6 and there is only 1 entry for R5. You know why R7 is having these 2 entries for R6? Because from R7 to reach R6, the cost is equal either via R5 or via R8. It can reach this R6 via R5 as well as R8, because this link in between R5 and R6 is also participating in area 2 itself. And small I is there because these ABRs are existing within our area. Hey, these ABRs are present within an area 2.
Yes.
That is why small I is there. But if anyone is present in different area, then definitely it will show you capital I. Right? So from R7 it is performing equal cost load balancing to reach R6. That is why it is having 2 entries. In same manner, if you move on, see, it can reach this R6 out from S1 by 0 as well as S1 by 1. It means R7 can reach this R6 out from S1 by 0 as well as S1 by 1. In same manner, you can move on R8 as well. From R8 also you can run this command show IP OSPF border router. It will perform load balancing for R5. But you know, if I put the link in between R5 and R6 in area 1 itself, then R7 and R8 will never be able to perform equal cost load balancing. If I put the link in between R5 and R6 in area 1, then R7 will not be able to perform equal cost load balancing, because it will become now inter area via R5 and R6, right? Via R5 to reach R6 will become inter area. So intra area will always preferred over inter area. You must remember this path selection process of OSPF actually. Like by default, intra area will always preferred over inter area. Inter area will always preferred over E1 external type 1, right?
Yeah.
I mean OE1, and OE1 will always preferred over external type 2, and then external type 2 will be preferred over ON1, and ON1 and SS external type 1 will always be preferred over ON2. OSPF external and SSA type 2. Wow. Great. Timings are 9:30 and you are coming at 10:10. Great. Fine. So this path selection process will always be followed by OSPF, and remember, you cannot manipulate it by modifying either AD value or metric. This path selection process of OSPF cannot be modified by manipulating their cost or AD value, administrative distance value. Tell me, any problem?
Maybe with prefix length, will it be possible?
I said metric
Okay.
and administrative distance value. I never said that okay, with using prefix length or something like that you cannot manipulate it. I said with using, by manipulating its cost, I mean metric or administrative distance value, you cannot manipulate the path selection process of OSPF. Fine. Okay, that's true, and I'm going to prove it now that okay, it is happening here. See, first of all, I will teach you that okay, intra area is always preferred over inter area. Try to take an example in perspective of R2. From R2, you can reach the loopback of R9 via R1 as well as via R10. Try to understand my point. From R2, you can reach the loopback of R9 via R10 as well as via R1. But via R1, it will receive it as inter area. However, cost will be just 128. You can check it. Cost will be simply 128 because on serial interfaces by default their cost is 64. And it can also reach it via R10, and this time via R10 its cost will be 192. But via R10, because it will come as intra area, whereas via R1 it will come as inter area, inside area 0. You understand? So which path should be preferred? Intra area means via R10. And let me show you the routing table of R2 now. Show IP route 9.9.9 is via R10. However, in from it is showing you the router ID of the originator router itself, R9. Hello?
Yeah.
Of course it will show you. Even if you move on R7, see how many routers are participating in area 2? 4. It means R7 is getting information from 4 routers. So that is why if you move on R7 now, and if you configure this command, show IP protocol, gateway of information, 3 routers, because it is getting router addresses from 3 routers, 8, 5 and 6. You understand? So in routing table also, if you see routing table in detail, like show IP route 8.8.8, it will show you from 8888. However, you understand? Even if you check the database, okay, let me move back again on R2 itself. So as I said here, see, as I configure this command show IP route 99999, so it is showing you from 99999 in its routing table itself. That's why we always says that OSPF is a link state routing protocol. And I have already taught you that why it is having the concept, the feature of distance vector routing protocols. I already taught you, because for some RLSs it will be depending only on that information which is given by, which is provided by ABR only. It's not it. So this time you can trace route to reach 9.9.9.9. You will see that it is going via R10. But in case if you shut down its serial 1/2, you will see that it will start to go via R1. See trace route. However, you see show IP route 9.9.9. Now its cost is what? Just 129. But in case if its S1/2 comes up once again, so you will see neighborship will come up via S1/2 now.
So in this case, SPF
And you see,
will run
yeah, of
area
course,
3.
of course, of course, because this interface was participating in area 3 itself. This is 1 by 2 of R2. So IP route. Metric is what? However, metric is higher.
Yeah. But it will be preferred.
So have you proved it or not?
Yes.
That metric will not participate in path selection in between if you are selecting path like intra area and inter area. So intra area will always preferred over. Now tell me why. Fully linked state.
Yeah.
Intra area is what? Fully linked state routing protocol. Whereas in case of inter area, it will become partial linked state routing protocol. So of course it will definitely, yeah, it will be having some features from distance vector in case of inter area routing. But if you are having intra area route, it means it is more trustworthy than inter area, because intra area means you are trusting on source of the route itself. You are getting information from the source of the route itself. But in case of inter area, you are getting information from the ABR. Behind ABR, who is generating that prefix, we don't know anything. Are you getting my point? That is why intra area is always preferred over inter area. That is why here, what can you do? If I see this time route metric, it is showing me from 99999, right? When it is coming as intra area. But if I shut down this link once again, you will see this time from 111, because it got this information from ABR. And who is working as an ABR? R1. So we are depending on that information which is given by 1111. This information is told by 11111 that you can reach this 9999 via me. So this time we are not getting information from the exact router, from the exact source. I hope you are getting my points.
Yes.
Once again, it will start to prefer this intra area. Fine. That's done. Now, we can also manipulate path selection with using metric as well. But from both neighbors, it should receive routes as either intra area or inter area. Let's take an example of R11 now. R11 is performing some kind of load balancing here. You know why? So IPOSP border router. So here you can see that from R11, the cost to reach both APRs is same. So if you are having any prefix for which you are having same cost from R1 as well as from R2 to reach them, like for an example, the network in between R3 and R4, for this network, the cost from R1 as well as from R2 is same. The network running in between R5 and R6, the cost from R1 as well as R2 will be same. So you can see on R11, it is running equal cost, it is performing equal cost load balancing for 34.1.0 network. See, is not it?
Yeah.
Here I'm not gonna show you complete routing table, because if you're having like thousands of routes inside your routing table, how will you check it out? So that's why I'm just trying to make you familiar, trying to make you used to that. Okay, how can you see routes in your routing table as well? It is not necessary to check whole routing table. It is not necessary to check the whole database table as well. So it is performing equal cost load balancing for this particular prefix, as well as you can see for 56 as well, 56.1.0, it will perform equal cost load balancing. Even if you check for 78 as well, actual IP route 78.1.0, it is performing equal cost load balancing. But for 7.7.7, no, not at all, which is available on R7 itself, right? So this time is best part to reach R7 is what? Via 1111, because this information is given by R1. And even let me show you. See, show IP OSPF border router. Let me prove it. Show IP OSPF border router. The cost to reach both ABRs is same from here. Then you do one thing, open summary LSA, because this is inter-area prefix and it will come in the form of summary LSA, and those summary LSAs will be generated by R1 and R2. Because for area 3, R1 and R2 are working as an ABR. So if you open database table summary, like for 7.7.7, you can see that it is generated by R1 and R2, both of them. See, R1 as well as R2. Now R1 is saying that the cost to reach this prefix is what? 193, whereas R2 is saying that the cost to reach this is 257. Whereas from here the cost to reach both ABRs is same. So the total, entire cost, the cumulative cost would be higher via R2 than via R1. That is why its best path have been configured, have been elected via R1. So I hope you people have understood it now. Have you understood it? Are you okay with this concept or not?
Yes,
Yes.
So now you can see show IP route 7.7.7, its best path is via R9, R9 R1. You can trace route it like it is going via R9 and then R1. But if you trace route 88888, then it will go via R10 and then R2. So it's very simple to identify that which path will be best path. So let's assume that right now R11 is performing load balancing for 34th network, even for 12th network as well, for 56 as well as 478. R11, right, is performing load balancing. So IP route even 12.1.0 is performing equal cost load balancing. So what I want, it should be preferred via R9 for all those prefixes for which it is performing equal cost load balancing. So what can we do? We can move on S1 by 0 and IP OSPF cost is what? 100 in place of 64. So this time you will see that the cost to reach ABRs from here will be different. To reach R2. So the entire cost, the total cost, cumulative cost will also become different now. Have you understood it or not?
Yes.
And from both neighbors it was receiving prefixes as inter area. It's not like that from one neighbor it is receiving it as intra area, from another neighbor it is receiving inter area. So definitely it will prefer intra area, right? But this time from both neighbors it is receiving those prefixes as inter area. Inter area. Hey guys, try to understand. Like 12th network, 34th network, 56 network, 78 network, all these networks are coming as inter area prefix. So this time you can see show IP route. Previously it was performing equal cost load balancing for 12th network, but now it is not performing, right? Its best path is via 11111. Even you can also check it out for 34th network as well via R1 itself. Is not it? Show IP route 56.1.0 via R1 itself. Show IP route 78.1.0 via R1 itself. So its best path have become via R1. So in this way you can perform path manipulation in OSPF by modifying its cost. Let's move back again on S1 by 0 and you configure its cost as 100. Just remove it. So again it will take its default cost, which is 64. Understood? So IP route, once again it will start to perform equal cost load balancing. You see, that's very simple in OSPF to perform path manipulation. But make sure that from both neighbors it is receiving your routes either as intra area or inter area or external or whatever it is. Fine. Okay. After it, let's go for redistribution now. Redistribution. Type 5 LSA as well as Type 4 LSAs. However, I have already taught you that what is the meaning by Type 5 LSA, but today we are going to talk about E1, E2 and all these things. Are you getting my point?
Yes.
Great. And this time, let's say there are two internet connections. Like here you can see EICRP is running here, and let's say here it's RIP, and here also you are having the same prefixes 120. Let's say there are two different internet connections. Are you getting a point or not?
Yes.
There are two different internet connections, so you have taken two different connections from two different service providers. One is running EICRP, one is running WIP. You are receiving same prefixes, you have to redistribute them into OSPF. And then you have to select the best path to restamp. For some of them, the best path will be via R11. For some of them, their best path will be via R8. So let's see that which one will be preferred. I hope that you people are getting my point. Fine. So let's configure these things first of all. So on R13, let's have the console of R12 as well as R13. EIGRP is already configured here. Let's have the console of R13. I have to change their IP addresses of loopback interfaces actually, because 130 is configured. Now move on R11, check show IP route EICRP. All 120 prefixes are coming here, right? In same manner, I will move on R8, show IP route with same prefix length, right? Now I have to redistribute them into OSPF on both routers. Fine. Let's start it. On R11, redistribute.
Autonomous system subnet.
Fine. And by default, they will go as E2, external type 2. Let me show you. If you have redistributed anything into OSPF, and if you want to confirm whether redistribution was done successfully or not, if you want to know that whether redistribution was done successfully or not, for doing that, command will be show IP OSPF database. If you find type 5 LSS available inside your own database table, it means redistribution was performed successfully. So this time you can see that all these type of LSS are available here and generated by R11 itself. It means redistribution has been performed successfully. Now if you want to open type 5 LSA, then the command will be show IP OSPF database external and then any link ID, like I wanted to open for 120.1.0. So open it. So as I said that by default, see, first 20 bytes will be same up to length, and then after changes will be there, right? So this time you can see that network mask is /24, whereas metric type is 2. I said by default your prefixes, your redistributed prefixes will go in OSPF as external type 2, and the same thing is happening here. Metric is by default 20 here. That is why we were not required to specify metric during the redistribution here, unlike EICRP. Like in EICRP, it is always mandatory to specify metric during redistribution, as we have already gone through it. We already discussed about it, right? So it is really mandatory that your metric, seed metric must be specified over there, right? So because seed metric is mandatory, and here by default, OSPF is having its default seed metric, which is 20. So its seed metric is 20. That's why it is having this metric 20 here. However, metric type is 2, and type 2, the meaning by type 2 is what? Larger than any other link state path. Larger than any other link state path. So what does it mean? That it is not going to compare it with any other link state path, because it has already assumed that, okay, my metric is larger than any other link state path. Are you getting my point or not? That is why in case of E2, the total cost will never be shown in routing table.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.